Okay. You guys okay? All right. So this year's exam, what is it going to consist of? It has three basic categories. And out of those three basic categories, we have subtopics. We have general mathematics, geometry, and differential calculus. So relax before you guys start freaking out like, oh my God, there's calculus. The calculus that is in this exam is not heavy. It's supposed to be light. So good thing that we're in calculus because this should be calculus questions that we're going to get correct. So what's going to be on this exam? So you guys all have a copy of this. Basic algebra operations, multiply, divide, add, subtract. Number sets, that means like grouping numbers. Applied word problems. In geometry, what are we going to have? Properties of shapes, spatial relationships, area, volume, and coordinate geometry. Think Pythagorean theorem, think distance, think midpoint. Don't worry, we're going to cover all the subtopics, all of them. Now, for differential calculus, what do we have? We're going to have basic limits. Notice the word basic. So don't freak out. It's not going to have the fancy ones that we're going to do in class. It's going to have the basic ones. Concepts of derivatives, like instantaneous rate of change, average rate of change, and the power rule for derivatives. Don't worry, we will talk about that. Are we okay? We're okay? Okay. So now let's start chatting about limits. Relax, guys. Let's chat about basic limits. That's what we're going to start about talking today. So what is a limit? So it says here, Gonzalez, do you want to read this for us? Yeah, read the whole thing.
So let's chat about basic limits today. All right, let's start with limits. What is a limit?
Yeah.
What does it mean to find a limit? Let's start with notation and go from there. The notation of the limit will look like the limit of x approaches c of f of x equals L.
Wow, how'd you know how to say that? That's amazing. Keep going.
Relax, it's not that bad. This is red. Oh, the limit of f as x approaches c is equal to L. If you want to call the function f of x, then you could also say the limit of f of x as x approaches c equals L. Basically, informally, a limit is a y value which a function approaches as x approaches some value. The limit of x approaches c of f of x equals L means as x approaches c, f of x approaches the y value of L. You will also see.
Oh, yeah, it goes to the next page?
Yes.
Oh, that's weird.
Oh.
Because mine doesn't go to the next page.
The limit of x approaches c from the left, right?
Yeah.
Of f of x equals L, and the limit of x approaches c from the right of f of x equals L. This means x is approaching from the left or the right, respectively. Let's practice finding limits graphically and using correct notation. The graph. Did I read that too?
Yeah, go for it.
The graph to the right is f of x equals 2x squared plus 5x minus 3x over 2x squared minus 9. The coordinates of the
over x squared minus 9, but it's okay.
Oh yeah, over x squared minus 9. The coordinates of the hole in this graph are -3 and -3 and 7 over 6. The red dashed line is the vertical asymptote x equals 3. The blue dashed line is the horizontal asymptote y equals 2. Let's chat #mathlife. Let's see how we could obtain the sketch above using simple analysis that we have learned from our previous math courses.
Okay, guys, I would like for you to be able to tell me real quick what the horizontal asymptote is just by looking at this. Remember your end behavior as x approaches positive infinity and negative infinity. So it's about end behavior. The spit and the ocean. The ocean in the numerator is 2x squared. The ocean in the denominator is x squared. Child, what are you talking about? When you spit in the ocean doesn't rise. Do you guys know what I mean when I say that? So that 2x squared, that 5x minus 3 is spit, and that minus 9 is spit. The 2x squared and the x squared is ocean. Notice that the x squareds cancel out, and you just get 2. That is your end behavior. So your horizontal asymptote is y equals 2. End behavior deals with horizontal asymptote if it does have an end behavior. If you get a nice little number, then that's it. Does that make sense? Yeah, and it's okay if it doesn't, guys. So my end behavior again. So this is for this right here. So that's how we got the horizontal asymptote. Now the vertical asymptote, guys. Notice that the 2x squared plus 5x minus 3 you could factor out, right? So 2x and then x, And then the 3, you're going to get that by doing 3 and 1. Now, remember, I have to add up to a 5x. So this one's going to be the plus. This is going to be the minus. And I know, we went through that really fast. You got to have to be somewhat kind of fast with factors, guys. Remember, we're not going to have calculators this year. And on the bottom, that's the difference of squares. So you're going to write x plus 3, x minus 3. We're not going to have calculators, so you got to be able to do that kind of fast. Notice that the factor, remember, multiplying and dividing are inverse operations. So this x plus 3 cancels out because you're multiplying on the top and you're dividing, so that x plus 3 cancels out. Now remember, you're still not defined. You're not defined at -3 and you're not defined at 3. Chop, why? Because you can't divide by 0. You can't. Does that make sense? So I have a whole at whatever factor cancels out. So I canceled out those x plus 3. So that means you have a whole at x equals -3. Whatever turns that x plus 3 into a 0. Talk to me, Hernandez. You okay? Okay.
So basically, like, wherever it cancels out, so be it like x plus 5 and x plus 5 in the bottom, there's going to be a whole at x equals -5.
Heck yeah, good job. You see, you're getting better. Boom. So there's going to be a whole at that whatever factor cancels out. So how do you find that whole? Well, you just plug in -3 into whatever you have left. So 2 times -3, -6 minus 1, -7, see? Over -3 minus -3, -3 minus 3, that's -6. Negative divided by a negative, positive. So I have a whole at -3, 76, which there it is, -3, 76.
Valeria Maldonado, report to the front office.
Okay.
Valeria Maldonado.
I think they called you.
No,
That was a joke. Hey, I didn't know you guys were sisters, by the way. Well, now I do. Okay. Does that make sense? Okay. Vasquez, you okay?
Yeah, okay. I'm a little bit confused.
Hit me.
Okay, can you really explain the 7, like where we got the -7 and -6?
Yes, I plugged in the -3. No, you're fine, you're fine.
It's just like I got lost a little
You see
bit.
what I have left? The 2x minus 1 over x minus 3?
Yeah, and you got that from the main equation, right?
Yeah.
Okay.
Yeah, well, I expanded that, and then I canceled.
Okay.
And then what's 2 times -3? Negative
Six.
-6, and I subtract 1, -7. And then -3 minus 3, -6. So negative divided by negative?
Positive.
There you go. Do you see how we did it?
Yes.
Okay. All right, there it is. Let's get to using limit notation. So here it is. Now, some of my kids already did it, so if they're faster, so she's fast, relax. It's because she already did it. So, see, that's what we're, okay. So it says here, as x approaches -infinity, the graph of f of x, so that means look at y value. Look at y value. So as x approaches -infinity, what does this y value approach? So here it is. Look at that green line. As that green line approaches -infinity, what is the y value that I'm approaching? I'm approaching the y value of that blue line. What is that y value? What's the blue line? What's the y value of the blue line? 2. So I'm approaching 2, guys. So put 2. How do I write this as a limit? Limit as x approaches -infinity of this function equals 2. Oh, I found out who your twin is. It's a lady named Morales. Because you're not a junior, right? See, so I still think she sits over there. Okay, sorry. Do you know who I'm talking about, Rodriguez? Someone named Morales? I don't know her first name.
I think so.
But doesn't she look like her a little bit?
I guess like a little bit.
Oh, okay. Well, then maybe I'm okay. You guys still okay over there? All right, look what happens. What is happening as x approaches positive infinity? So what do you think, Hernandez? As x approaches positive infinity, what is that y value approaching? I'm approaching that blue dotted line or blue dashed line. Not dotted, but dashed. So what's the y value of the blue line? 2. There it is. How do I write it? Limit as x approaches infinity. And you don't have to say f of x. You can say the whole function. 2x squared plus 5x minus 3 over x squared minus 9 equals 2. Do you see how we did it? Okay. Limit as x approaches as x approaches negative 3 from the left to the graph of f of x, okay? Notice from the left. So I'm approaching negative 3. Here's negative 3. If I'm approaching from the left, so you're going to write it like this. Well, I'm approaching that hole. That hole, let me go ahead and write that negative 3, comma 7, 6. I got that from earlier, from right here, see? So we don't care that there's a hole there. All I care is that I'm approaching it, that I'm converging at that value. So limit as x approaches negative from the left of the graph of f of x is 7, 6, like that. 6, 7, 7, 6. So here's how I write it. Limit as x approaches negative 3, and I'm approaching from the left, so put a little minus sign in the upper right-hand corner, like that, of this function, f of x, equals 7, 6. Are we okay with that? Okay. Limit, so it says as x approaches negative 3 from the right, so from the right, the graph of f of x equals, well, if I approach negative 3 from the right, I'm looking at that curve, that y value is still 7, 6. So I write 7, 6. Limit as x approaches negative 3 from the right of this function, f of x, equals 7, 6. Are we still okay, guys? Tell me, Vasquez. We're okay?
Is that negative 3 right? Yeah.
That's negative 3, but I'm approaching from the right-hand side, so I put a little plus symbol.
Oh, okay.
So the little plus symbol means from the right. The little minus symbol means from the left. And don't worry, we're going to have practice. We're going to have delta math in a little bit. As x approaches negative 3, both of these match. See how that's a 7, 6 and that's a 7, 6? So you're going to say that this graph approaches 7, 6, that same y value. Because look, if I approach negative 3 from the left and from the right, I'm converging at that 7, 6. I know this function is not defined at negative 3, but we don't care. We just care about where we're approaching. Are we okay? All right, so there it is, guys. So we're going to write it like this. Limit as x approaches negative 3. Now I don't put a little symbol in the upper right-hand corner at all. So of this function, f of x is equal to that 7, 6. If the y values were different, if this was a different number than this, then we would do the Lindsay-Lohan, and we would say the limit does not exist.
So
But
the limit does not exist, it's 0, right?
no, it just does not exist because there's no number. So if that's, hey, relax, we're rookies, it's okay. It's a safe space. If these numbers do not match, you're gonna say the limit does not exist. Okay, are we cool?
Yes.
Hey, what's going on, Taylor? Yeah. Okay, see if you can do these next two guys or these next three, and then as soon as you guys do them, I'll do them right now with you guys.
So, to do 17, I just used the example, but I had missed this example, so I just wanted to make sure it's right. And then also I don't.
15 to 25, yeah, you did it right.
And then I don't understand like why you like divide by 360 and multiply.
Because when I divide by 360, it tells me how many revolutions I did. So that 15 means that I did 15 revolutions. And that 0.225 means 22.5% of a revolution. So that's why you're doing 0.225 times 360. Because it's 22.5% of a revolution. So if you want to know how many degrees you went, you go 0.225 times 360.
Oh, okay.
You know what I mean?
Yes. Okay. Thank you.
All right, Ms. Vasquez. Sorry, I'm not picking on you. There's a free. Okay. Look what it says here. So guide me. So can you read that for me?
Okay. As x approaches 3 from the left, the graph of fx is
Perfect. So if I approach 3 from the left, notice that I go down forever. So if I go down forever, what am I going to call that, Gonzalez? Negative infinity. So then you're going to write limit as x approaches 3 from the left, that's how you do it, of this function f of x equals negative infinity. All right, Mr. Hernandez, ready? Can you read this for us?
As x approaches 3 from the right, the graph of f of x is...
Okay, well, here it is. Here's the graph. If I approach 3 from the right, those y values just keep getting larger and larger and larger. I'm going to say positive infinity. Limit as x approaches 3 from the right of that function approaches positive infinity. right, ready, Gonzalez? Do these behaviors match?
No.
So then we're going to say
Design
does not exist. Limit as x approaches 3 of this function does not exist. Some might say they don't like the equal sign. You can't equal does not exist, but I'm okay with that. Some textbooks would probably just say don't have the equal sign and just write does not exist. How do we feel? Yeah. Then I have some rules here. Sorry that the formatting looks weird. There should have been a box right here like that. So all that means is if you approach from both directions and it equals the same value, then that's what the limit is. That's all it means. A function has a limit as x approaches c if and only if the right hand and left hand limits at c exist and are equal. In symbols, here's how it looks. Hey, what's going on, Swanks?
Hi, do you have a really long HDMI cord that I can either borrow or have?
Well, the really long HDMI cords that I have right now are both going to both of these. I'm sorry, Swanks. Okay, ready for this, guys? Okay, so help me. How do I read this right here? Letter A. So we'll go with you, Ms. Vasquez. Don't worry, it's a safe space. Letter A. So it's limit. Okay.
The limit approaching from x to -1, right?
Yeah. So limit as x approaches -1 from the right-hand side of f of x. So you can also say limit of f of x as x approaches -1 from the right. So here it is. Here's -1. There's only one way to approach. So if I approach -1 from the right, that limit is 1. Yeah, there it is. That's it. All right, ready or not? Read this statement. Limit
Of f of x approaching
limit of f of x as x.
as x approaches 1 from the left.
Perfect. What is that limit? So if I approach 1 from the left, what is that y value that I'm approaching?
1.
No, not 1. You're looking at the curve and you're approaching 1 from the left. So look at the board real quick. So here it is. Here I'm using my laser. If I approach 1 from the left, I'm approaching, what's that y value? Yeah, what's the y value? I think I heard you say it. 2. There it is. All right, Gonzalez, hit me with letter C.
The limit as x approaches 1 from the right of f of x equals 1.
There you go. All right, what do you think, Vasquez? Limit as x approaches 1 of f of x. What do you think I'm going to say?
1.
I don't know. Do these, look at 1. From 1 from the left, it's 2. 1 from the right, it's 1. Do they
Is
match?
it 3?
No.
Oh.
No, it's okay. It's okay. It's okay. Limit as x approaches 1 from the left is 2. Limit as x approaches 1 from the right is 1. Do they match?
No.
No, because they don't match. What are you going to say?
Exist.
Does not exist. See? Limit as x approaches 2 of f of x. Well, it just says 2, so I got to check from the left and the right. If I approach 2 from the left, if I approach 2 from the right, what y value am I converging at? Yes, ma'am.
Do you guys have quote functions?
I have one right there next to that little statue. So where am I converging at, guys? It's behind the gloves. It's behind the gloves. Yeah, just take out the gloves. It's in the bookcase.
Okay.
Right there. All right, guys, so what's that value? What's his limit? Yeah, it's 1. Look, if you go from the left and the right, I want it back, guys, and make sure you bring it back.
Yes, we'll bring it back.
All right, limit as x approaches 3 from the left. If I approach 3 from the left, what's that y value? 1. There it is. Does letter G have the word limit on it? No, so that just means f of 2. So look for where you're defined. F of 2 equals 2. See? Are we getting this, guys?
Yeah.
Okay.
That one's easier than the other one. Like, no.
Yeah, it just takes practice. No, they're all about the same, I think. All right, let's keep doing this. This is what you're going to do today, guys. I really want you to take care of this delta. I know it's not for a grade because we don't have a class. But guys, like we want to go to state, and we're only going to get there if we practice. All right, so here we go. Answer all the questions below about the function f of x graph below when x equals 3. Limit as x approaches 3 from the left. So if I approach 3 from the left, what y value are you approaching? Yeah, just put it back. 1. You're approaching 1, see? It's a y value. All right, Hernandez, help me out with this one. Limit as x approaches 3 from the right. What's that y value? Don't say it out loud. Yes, good job. Look at you. You did it, miss. All right, Vasquez, ready? So limit as x approaches 3 of this function. If I approach from the left, I got a 1. If I approach from the right, I got a 3. Do they match?
No.
So what? Does not exist. F of 3. Notice at x equals 3, you're not defined anywhere. Those are all holes. So you're going to say undefined.
So I actually have a question about this.
Yes.
If the whole scope, like if it's a dot,
Then now you're
then
defined.
that would
What?
be okay. I just didn't know if that had to be like a singular dot or something.
No. It can be a dot there. It can be a dot by itself. And so that would be the value. You good? All right, here we go. This one's probably the hardest one in there, but it's not that bad. It wants to know where is the limit as x approaches a equal to 0. So I would probably draw right on the x-axis, and don't worry, guys, we're almost done. So here it is. Here's my x-axis, and I would see where I have a limit that equals 0. Now remember, the y value is 0 on the x-axis, so I see it there. I see it right there. And then be careful here. It has to approach from both the left and the right. So I see 2 of them. So here's how I would write it. Limit as x approaches -5 of this function equals 0. Limit as x approaches 2, I think that's a 2, yeah, of this function equals 0. And limit as x approaches 8 of this function equals 0. Do you guys understand how I got those values? Because I want the limit, I want my y value to be a 0. And those are the only 3 where they're converging from the left and the right where the y value is 0. So these are what the numbers I want. I want that number, and that number. So you're just going to say a equals -5, comma, 2, comma, 8. Okay, make sure to look at my video, miss. Give it a thumbs up so I know it's real. And remember, miss, we're trying to go to state.
I know.
So
I'll do the delta time and I'll watch the video.
okay, I'll give you the code. Are you in AP Classroom?
Oh, I saw the code though on Ruby.
Okay.
Right? Wait, is it AP Classroom or Google Classroom?
Google Classroom. Yeah.
Alrighty. Well, bye guys.
You're fine. You're out. Later. All right, ready, guys, for the sketch of the graph? I think it's probably best. I mean, you can answer this question without having to sketch a graph, but let's sketch a graph. This is what we had issues with, right? You see? I think you are, miss. I think you are. Let's see. So here we go. Ready? At x equals 0, this y value is 1. There you go, Ms. Yashnitz. We are starting in the piecewise function, but it's
Okay. Okay.
At x equals 0, what is 0? Later, miss. What is 0 plus 1? 1. So at 0, put a point at 1. So here's 0. I'm going to say that's 1. At 1, -1 plus 1 is 0. So here's 1. And I'm going to put an open circle, and I'm going to connect those 2 dots. These are all linear. Does everyone know why it looks like this? Okay, check it out, Hernandez. Why does it look like this? Look at my domain. It's between 0 and 1. So between 0 and 1, I have to have a slope of -1, and my y-intercept is 1. So here's my y-intercept, and my slope is -1. Right at x equals 1, there's not an equal sign there, so it has to be an open circle. Are we okay? Okay, we got to get these questions right, guys. We want to go to state.
Yay!
No, we are. We're going. Here we go. No, we're going to say this is why we're doing this. We went right into limits, right into the big dogs. All right, here we go. It is 1 between, the output is 1 between 1 and 2, between x values 1 and 2. So here's 1, and I'm going to put a point right here. That's a solid. And I'm going to call this 2 right here. I'm going to say that. I'm going to call that 2. And I'm just going to write a linear line that's always 1 between 1 and 2. And at 2, I put an open circle. Why am I putting an open circle there? Yeah, there's no equal sign right there. So it's 1 between 1 and 2. And there it is. Are we okay so far?
Yeah.
All right. At x equals 2, it says that I'm 2. So I'm just going to put a point at 2, 2. I'm going to say 2, 2 is right here. 2, 2, point right there. So look, I'm color coding them. Chav, I don't know how to do the next one, x minus 1 between 2 and 3. Look, it's a linear line. Plug in a 2. What's 2 minus 1? 1. So I'm going to go to 2, 1, and I'm going to put an open circle right there at 1. See? And then I go to 3. What's 3 minus 1?
2.
So I'm going to go to 2, and I'm going to put a solid. So here's my solid. And it's a linear line, so connect them. Bam! See? There it is. All right? Okay. So here we go. Let's go to the next one at 4. That's at 3. It's not perfect, but that's fine. At 4. So at 3, negative 3 plus 5 is 2. So I'm right here. I know it's an open circle, but the purple one fills it in. So we kind of don't really have to worry about it. And then at 4, negative 4 plus 5 is 1. So I'm going to go back to 1. I'm going to put a solid circle. And I'm going to connect them like so. I'm trying to get the little purple. There we go. All right, there we go. I think we're, the 3 looks funny. Okay, how do we feel? All right, so here we go. Ready? This is called the limit, Miss Yoshnitz. Have you seen it before or no?
No.
Okay, it's really, you'll catch up really quick. But just watch the video from the beginning and you'll be even better.
All
right, so how do we read it? Limit of f of x as x approaches 0 from the what side? From the right. There's only one direction, guys. You can only approach 0 from the right. So look at this graph. As I approach x equals 0 from the right, I look at the curve, guys. What is that y value? What am I converging at? 1. That's what that limit is. I'm going to put 1. 1. Letter B, or it doesn't have letters. It's just, all right, I'm going left to right. So, Miss Gonzalez, can you tell me how to read this? Not only read this, but what the answer is. So read this one.
The limit as x approaches 1 from the left of f of x equals 0.
Perfect. That's a y value. Yeah, she's fast because she already had calculus.
X approaches 1.
Yeah. Let's say it again. You can say it one of two ways. Limit of f of x as x approaches 1 from the left is 0. Or you can say limit as x approaches 1 from the left of this function is 0. So here's x equals 1. If I approach 1 from the left, so here's my curve. If I approach 1 from the left, the y value, you don't care that you're undefined. The y value that you're converging at is 0. Yeah, you don't care that you're undefined. You just care about where you're going. So sometimes you'll see me do this before, that's because we just care about where we're converging at. You know what I mean?
Wait, how did you say it again? As x approaches the left?
Limit of f of x as x approaches 1 from the left.
1, is it limit of f of x?
It doesn't matter. Both are the same. A limit as x approaches 1 from the left of f of x, or limit of f of x as x approaches 1 from the left. Both are the same.
Oh, so what's the difference between the negative and the positive?
Perfect. Good question. The minus 1 means left. The plus 1 on the right hand corner means right.
Okay.
So now you're next. Ready, Ms. Yashnet? This is a safe space. So you're okay.
Okay.
So I'm gonna say this one for you, and then you'll do the next one.
Okay.
Limit of f of x as x approaches 1 from the right is, so I go to 1 and I look at the curve where you're at. If I approach 1 from the right, what is that y value?
1?
1, yeah. Congratulations, you did your first limit. All right, so now read this statement for me, and then we'll talk about the analysis.
Okay. Wait, what happens if there's like no plus or minus?
So you're just going to say limit, when you get to that point, you're going to say as x approaches 1.
Oh, okay. Limit of f of x as x approaches 1.
1 is, what is that? It's the Lindsay Lohan one. If I approach one from the left, it's 0. If I approach one from the right, it's 1. Do they match?
No.
Because they don't match, you're going to say what? Remember? No, what did Lindsay Lohan say? Did you ever watch Mean Girls?
No.
Oh, tell her what Lindsay Lohan says.
The limit does not exist.
The limit does not exist.
Like the output, like what's the endpoints or outputs?
The output and the y values?
The outputs of what they have to match. So they both have to equal 1, they both have to equal 0, and if they don't equal the same thing, then they can't exist.
Okay, so the answer is that.
Does not exist.
Okay.
Don't worry, guys, we're almost done. All right, limit as x approaches 2 from the left. What is that limit, guys? 1. Limit as x approaches 2 from the right. Limit of f of x as x approaches 2 from the right. Here's 2. If I approach 2 from the right, I'm still converging at that same y value, which is 1. Miss Yushnis, do the left and the right match as x approaches 2?
Yes.
So I'm going to say the limit of f of x as x approaches 2 is 1. There you go. All right, Hernandez, ready for the next one? Limit, oh yeah, hook me up, Hernandez. You tell me the whole thing.
Limit of f of x as x approaches 3 from the left is 1.
No, not 1. Look at the curve. What's that y value? Here's 3. Here's 3. I'm approaching 3 from the left. So if I approach 3 from the left, what's that y value? Yeah, 2. All right, hit me, Gonzalez.
The limit of f of x approaches 3 from the right of f of x equals 2.
Perfect. All right, Ms. Yashnitz. Bottom left.
2.
Yes. But give me the whole
Oh.
spiel.
Limit of f of x as x approaches 3 is 2.
Perfect. Good job. All right, Hernandez, hit me with the next one.
Limit of f of x as x approaches 4 from the left is 1.
Perfect. Last one, Gonzalez. Does it say the word limit?
No.
It doesn't. So it just wants to know when x is 2, what's my output? 2. Good job, guys. All right. The last question, and then we can get started with the delta. I'll give you guys the codes and all that. Let f be defined as follows. What is the limit of f of x as x approaches 2? So first, can you write me the limit notation? So let's see, who do we pick on? Let's pick on Yashnitz. All right, Yashnitz, don't worry, there is a safe space. Can you help me write my limit expression?
Okay.
Okay, tell me what to write.
L lim
LIM, okay, and then what?
and then f x
Okay, we can write f of x, yeah.
and then the x
Where do I put the x?
underneath
Underneath what?
lim
Yeah, x,
and then arrow
arrow,
2.
2, and then I put an equal sign.
Oh, equals.
All right, what? Now let's find out what that, can you, okay, so take a minute, see if you guys can figure it out. You already got it, right? Let me see.
I don't know. This one first. No, I don't think so.
Oh, you got it right?
Really?
Yeah. Is it making more sense?
Yeah, it's so
Good. I did this on purpose.
Did you really?
Yeah. I mean, if you can do anything, it just requires time. And this is, sorry, I know I'm recording, so. I want you to go to statements.
That handout that we didn't finish because of fire code, that's tomorrow.
Yeah, see if you
Can I
can.
get the handout that you said to you during class?
I did, I gave it to you. Oh, no, I didn't. You're right.
I was like,
It's right there, I think.
this is tomorrow, right? That one we got?
Yes.
That we didn't finish?
There's not one right there?
No,
Next.
these are the notes.
Excuse me. Oh, I was about to say I don't think I have it anymore. There you go. All right, guys, were you guys able? I know you got it. Were you guys able to get an answer? Okay. You can do this one of two ways. You can either look at it and be like, well, if I approach 2 from the left, let me write it like here, limit as x approaches 2 from the left of this function. So if I approach 2 from the left, guys, we got to focus on the top one because this is the only one that works if you're approaching from the left. So if you're approaching 2 from the left, I'm looking at this, so let's plug in a 2 there. 2 squared is 4 plus 1 is 5. But I don't know if that's the answer yet. We got to check both sides, right? So it's 5. So now I'm going to go limit as x approaches 2 from the right of this function. And then I'm going to say, all right, well, let me see. Let me approach 2 from the right. So if I approach 2 from the right, then I got to use this bottom one. And if I approach 2 from the right, look what it is. It's always what?
2. Oh, 5.
5. 5. Be careful. The 2 is where you're defined. We'll talk about that right now. 5. So now the left side, if I approach 2 from the left and 2 from the right, I get 5s on both. So then that means this one is just going to equal 5. Now that's one way to do it, but I know that you guys are visual. So let me draw the piecewise graph for you guys. So look, here it is. Okay. X squared plus 1, it looks like this, guys. So I'm going to write negative 2 right here. I'm going to write 2 right here. And it looks like this. Where that's 5. Wow, that came out ugly. 5. And then what's down here? That's just 1 because that's just a parabola with a vertex on the y-axis at 0, 1. And actually, this one's a solid circle. And then at x equals 2, it's 1. So I'm going to write a solid circle right here. And then look, it's 5 between 2 and 8. So I'm going to say that 8's way over here. And it's like that. And the 8 is an open circle. So now look, there it is, guys. So look what happens as I approach 2 from the left and the right. Am I converging at 5?
Yes.
So there it is. My limit is 5. Does that make sense?
Yes.
Okay. So there it is. I think we're good. And now you guys don't have this because I copied that from the Cal. But you guys do have a Delta Math. Let me give you guys the code for Delta Math. And I do want you guys to try this out. I would like for you guys to at least give it a shot right now.